di logical kidney kita nih ya. Hello guys, today's video gonna show you about the formation of urine. But before we get to know about how is the urine formed, of course we had to get to know about the system that works on the formation of urine. Now let's give it up to Kevin.
The human urinary system plays an important role in homeostasis. The function of the urinary system is to excrete nitrogenous compound waste and also take part in osmoregulation. First, let's take a look at the structure of our urinary system. The human urinary system consists of the renal artery, kidney, renal vein, ureter, bladder, and urethra. Urine formed in the kidney will flow into pelvis in the kidney, flow through the ureter into the bladder.
Now, let's take a look at the cross-section of the kidney. Our kidney consists of the cortex, medulla, pelvis, which is connected to the ureter, renal artery, and renal vein. Kidneys are made up of million nephrons, which is involved in formation of urine. Nephrons consist of three main parts, which is the Bowman's capsule, glomerulus, and renal tubules. The Bowman's capsule is cup-shaped containing glomerulus. Renal tubules composed of proximal convoluted tubule, loop of Henle, and distal convoluted tubule. The loop of Henle is U-shaped and extended to the renal medulla. Some of the distal convoluted tubule are joined together into a collecting duct.
Next, moving on the main purpose of the video, which is how is the urine formed. Production of urine involves three processes. First process called ultrafiltration occur in the Bowman capsule, where the blood that enters glomerulus is under high pressure because the difference between the diameter of efferent arteriole and efferent arteriole. This pressure causes ultrafiltration to occur and fluid will seep through the wall of glomerulus capillaries into the cavity of Bowman capsule. This fluid, now called glomerular filtrate, and it contains the same composition as blood plasma, but without red blood cell, platelets, and plasma protein, as its size are too big to seep out of the glomerulus.
So, before I start my yapping, please take a rest and enjoy the video. Alright, time's up. The second process is the process of reabsorption, and might I tell you that this process occurs in all three main parts of the renal tubules, of the nephrons, of course. First reabsorption is at the proximal convoluted tubules, or for short, PCT. Here, the sodium ions are actively pumped into the BCN, or blood capillary network, and chloride ions are passively absorbed. 100% of glucose and amino acids are reabsorbed too, through active transport. Since there are movement of dissolved substances between BCN and the glomerular filtrate, there will be difference in concentration of dissolved substances between the two places, and this allows the water to enter blood capillary network through osmosis. Next, reabsorption will occur at the loop of Henle and at the distal convoluted tubules, or for short, DCT. In loop of Henle, water will be absorbed through osmosis and sodium ions are reabsorbed through active transport, while in DCT, more water and more sodium ions and chloride ions are reabsorbed. And be aware that the amount of water and salt reabsorbed depends on water and salt content in the body.
Lastly is the process of secretion. This process involves the secreting of waste material in blood that weren't filtered earlier into the renal tubules. And this process is opposite to the process of reabsorption. Secretion occurs along the renal tubule and collecting duct and most active at distal convoluted tubule. It also go through simple diffusion and active transport. Substances that are secreted included hydrogen ions, potassium ions, ammonium ions, urea, creatinine, toxic substances, and some drugs. This process helps in getting rid of the toxic waste and help to regulate the level of ions in blood. When renal fluid reaches the collecting duct, there's only a small amount of salts are left and most water has been absorbed back into the bloodstream. The remaining renal fluid, now called urine, will flow down the collecting duct. Small amount of urea will diffuse out into surrounding fluid and blood capillaries due to its small molecular size. Urine containing water, urea, sodium chloride, salt, uric acid, and creatinine will flow through the ureter into the bladder, through the urethra, and finally it's expelled.